amazingly, we have an expert on memory to follow up. So, Chris Moore from
Micron.
From Micron. Just waiting for your applause to die down. Oh. Yeah, Chris Moore from Micron, VP of Marketing. A lot of experience in the memory industry, right? So
right. Memory and storage, yeah.
About 30 years or so.
Oh,
You don't look it.
All right.
Anyway, let me hand over to Chris.
Good morning, everybody. Thank you for coming this morning. My name is Chris Moore. I am the VP of Marketing in the mobile business unit at Micron. And yes, about 30 years in memory and storage, getting close to that. First, I want to thank Peter and Neil for the opportunity to be here. We get to talk about generative AI all the time in our industry, right? What's going on in the cloud. People talk about Skynet, people talk about Colossus and all these different things that are happening, but it's pretty rare to actually get to talk about generative AI and mobile. 1 second here. Today, I'm going to talk about enabling AI in your pocket. So, before diving into this presentation, though, a little bit about myself. I am a very rare, multi-generational Bay Area native. My great-grandparents, I'm told, started the very first camera shop in San Jose many, many decades ago. So you can see from that innovation is in my blood, right? Now, my cousins and I all wish they were more like real estate speculators, so that maybe I wouldn't be standing here right now. But grew up in the Bay Area, grew up in the halls of Intel. My mother worked at Intel for over 25 years, so I literally was walking through the cube farms of Intel as they were developing the Pentium, as they were developing floating point, and really got to see this technology blossom, this compute technology in the 90s blossom, and then was lucky enough to be part of the internet technology in the late 90s through the 2000s. And I graduated from Berkeley, 𝗀ECS, went to Intel, of course, because, nepotism. I left Intel in 2000. I went to a company called Matrix Semiconductor. And at Matrix, we were focused on 3D NAND. I don't know if you heard it before. As a startup in Silicon Valley, we were really hyper-focused on a couple of different markets. This was early 2000. We were focused on digital cameras, on MP3 players, and this new market that was starting to take off called cell phones. And one of the first things in the spring of 2000 that my peers and I started thinking about is, what is the definition of a smartphone? It's intuitive to us now, but in 2000, it wasn't. What we decided that spring was that a smartphone was a phone that had SMS, you could text back and forth, and had a digital camera built into it. At that time, that was very, very innovative. And there it is. Up on the left there is the world's first, by our definition at the time, smartphone. The Kyocera VP120, video phone 120. You could take pictures with it. You could send those pictures back and forth. It took forever, but it worked. It was the very first phone in your pocket with a camera. That launched in May of 1999. Shortly thereafter, there were a lot of copycats out there, right? But if we think about it now, and you looked at that picture 24 years later, would you think that that was a smartphone? No. It took 7 years, and then what I would call the real smartphone took off. And we all know its name, though I'm not going to say it here, but it had a touchscreen on it. And it had apps, and it had 3G wireless. All of a sudden, you could really connect to the internet. You could really engage with this phone. And one of the key points of this phone that never occurred to us before it launched, or not immediately before it launched, was how you interacted with it, the interface. The touchscreen was fundamental. Fundamental. It made it intuitive for us as users to be able to use this phone. And that's what drove mass market, right? All of a sudden, everybody had one. I think today, 90% of people have a smartphone in the United States. Statistic I saw. At the time, 90% of people had cable TV, right? So that's how the world has really changed. Now, how important is that interface? Since computers have been developed, people have been struggling with how do we take our complex wishes, what we're trying to get done, and get the computer to do it for us. People a little older than me used to do punch cards and have a stack of punch cards going into computers at universities. People my age used to use MS-DOS, right? And then all of a sudden Windows 95 came out and the graphical user interface. The touchscreen was the equivalent of that. All of a sudden, it was very simple and easy to use. It was intuitive. Very, very key and important point. The next generation phones were kind of incremental, right? You have 4G, which is great. Now you can stream video back and forth. You can create content. You've got much better cameras than what you used to have. I like to think of it as a Swiss Army knife, right? It's an electronic Swiss Army knife. You no longer have GPS, right? No longer have dictaphones. You can do all your email on it. Everything you want is on this phone. It's great. It's really, really good at doing a lot of things. Today, we're living what I would call the fourth generation of phone. Unfortunately, it's still a bit of incrementalism, right? How you actually use your phone hasn't changed that much. They're foldable now, so you can set them down and take video easier. You can do your TikTok, you can take great pictures and great video. You can edit now on the phone. I'm a big fan of the large foldables because you can do a lot of multitasking now that you weren't able to do. But at the same time, it's evolutionary, right? What I want to talk about today is the possibility that there's a next generation of revolutionary phone coming out, the AI phone. And what we can see today, I contend, is similar to what we can see in around the year 2000 about the smartphone. I'm not going to claim to know what this phone's going to look like in 10 years. I'm very happy to say that a lot of what Vinesh talked about is aligned to what we're talking about here. It would have been pretty bad if our partner named Qualcomm came up and talked about stuff that is very misaligned with what you're about to see here. But it's actually very aligned. And Vinesh did a great job focusing on the SoC and everything going on the SoC and the system to make that happen. The key that AI brings to the phone today is exactly what the touchscreen brought 20 years ago. The ability to easily interact with your phone. Siri, Alexa, they came out 9 or 10 years ago, if I remember correctly. They're not perfect. They're not easy. But through a large language model, we now have the hope that we can interface with our phone directly with audio, with speech, and it will very intuitively do exactly what we want it to do. Instead of having to press 6 different apps, we can just tell it what we want it to do, and it will be able to decode it, decipher it, and give us the answer that we're looking for. It's clear to me that AI will allow the interface to be much easier than it used to be, and much more efficient. Just as it was clear to me in 1999 that a camera was an integral part of a phone. It's also clear to me that AI is going to change the way we query on a phone. That if you're using AI to go look for that picture of your kid at the football game from 3 weeks ago, it's going to know which picture you want to find. It's going to find it a lot easier than your traditional search methods. If you're going to query on your phone, it's going to also know to go to the cloud to find the data that you need. These two things are very, very clear to me. There's a lot of stuff that could be out there that we don't know yet. Will there be another social media? Will there be more economies built based on AI that we don't understand or see today? Because there's really smart people like you out there working on things. So let's talk about what it's going to take to make an AI phone and what it might actually look like. To do that, I think we need to start by what's happening in the cloud. Because, Moore's law, right? What's happening in the cloud today, over a long enough scale of time, is eventually going to get in your hand. What you see here is Jensen Huang's presentation from CES. What you see on the left side in the green are traditional neural nets and the complexities associated with them, how many petaflops it takes to run them. And then starting with the transformer model from Google, the pink line, you see it starts growing at an exponential rate. We all know this, right? We're all talking about what's happening in the cloud all the time. There's a tremendous amount of compute going into the cloud today to make this happen. Colossus, 100,000 H100 GPUs. That's just phase 1. That launched, about a month ago? Phase 2 is coming, 200,000 GPUs, 50,000 of which are going to be H200. There is a race in the cloud to get AGI. There's a race in the cloud to get to ASI, right? Artificial superintelligence. Everybody's trying to get there. How is this going to help us in your hands. How is it going to get to the cell phone? Now, there's one other critical point that Vinesh brought up a few times, and I appreciated it, and that is memory is really, really important when you're doing these models. This is from the H200 datasheet. The difference between the H100 and the H200 is not a lot of compute, it's actually a lot of memory. The H100 has 80 gigabytes of HBM3, right? That's running at 3.35 terabytes per second. The H200, basically the same compute system. The only difference is it's got 141 gigabytes of Micron's HBM3E, right? That's running at 4.8 terabytes a second. Just by changing the memory, you see Llama 2, 70 billion parameter files, runs almost 2x faster. So it's talked a lot about all of the compute that's going into the cloud. And for good reason, it's really important. What's not talked about as much is how there's a memory wall. And that we need to tear down that memory wall to really take advantage of that compute. The last thing you want if you're building a system is to have a very expensive, power-hungry processor sitting, waiting for data. And that's why I'm here, right? That's what I love to solve. Oop. So how are we going to solve it? It's going to take all of us together in the industry to solve this problem, to get it into your hand. We just listened to an excellent presentation on hardware, right? Their NPUs are getting better and better and better. We are moving from LP4X to LP5X to get faster memory. Storage has to improve. If you're going to have an 8 billion parameter file, and you will have an 8 billion parameter file in the next 3 to 5 years, you don't want to wait that 1 to 2 seconds for it to load. You actually want it to preload before you even think about it. That's going to take doubling the performance on your NAND. There's going to be a bunch of peripherals. Today, I have my watch, still turned on. I've got glasses. There's the Meta Orion. I don't know if you saw that. Came out a week or so ago. Very, very interesting things happening in the world of peripherals, hearables. You want all of these devices to talk to each other and to work through your phone seamlessly. Software. Software is really not talked about enough. It's actually really, really hard. Our partners at Qualcomm and our partners at MediaTek spend a ton of time optimizing the software so that you can actually run these models or run any kind of compute on your phone without draining the battery. Deploying a mobile system in an efficient way so that your battery doesn't die is really, really hard and takes a lot of effort. There needs to be a lot more work in that with these models. I'm going to show you in a little bit. There's going to be multiple models running at the same time on your phone. How are you going to be able to run multiple SLMs, small language models, or medium language models on your phone at the same time without having it die in just a few hours? Because you don't want that. You won't live with that. A lot of work has to happen there. The software also, over time, has to become contextually aware. It has to be able to take input from all of these different devices, know where you are. For example, let's say I'm hosting a Super Bowl party. I'm standing in line at the grocery store. I forgot to go get the dip. I want my phone to signal to my watch to remind me to go get that dip. I don't want to be walking out to the car and remembering that I forgot it. With AI in your phone, with all of these devices, with your phone getting to know you, and with the software able to parse the data and have it make sense and customize what you're looking for, this will be possible. This will be the AI phone of your future. Now, the other area of innovation that is happening already today, all of this is happening, but an area that's spending billions and billions of dollars of research on is artificial intelligence itself. Driving these artificial general intelligence systems, super intelligent systems in the future, takes a ton of power, a ton of compute, and is very, very expensive. So there's a lot of people that are researching, how do we make this more efficient? We talked about quantization earlier, mixture of experts, hybrid AI. All of these things are already being researched in the cloud, and all of that is going to help take what's going on in the cloud and put it in your hand. So this is a graph that I find really, really interesting. This is a multitask language understanding benchmark, okay? So it's a benchmark of an LLM. There's a lot of different ones out there that we've seen, right? For example, you have, take the SAT and see what score you get on the SAT. Try and learn French. Can you go read Shakespeare in French, right? They have all of these different things that they're trying to run LLMs at. This one is focused on just more, I would say, kind of common sense, contextual understanding. It shows in 2020 that ChatGPT 3, based on 175 billion parameters, scored about a little over 40. And you can see over time that's gotten better, right? 175 billion parameters. ChatGPT 4 is shooting closer to 90. Well, through quantization, through data filtering, which is hugely important, I'll touch on that in a second, Llama 2 in 2023 scored about the same thing as ChatGPT. Now, I want to be careful here. If you want to know the timetable from London to Heathrow, Llama 2 is not going to be able to answer that in this because it hasn't been trained on it, and that's data filtering. Data filtering is hugely important. You want to start training your models based upon what you want that model to do specifically. I saw a podcast the other day where they're talking about in order to get to true artificial general intelligence, they want to start training the models based upon our inner dialogue. I don't know how they're going to do that. I don't necessarily know what my inner dialogue is. That's a different story, but that's what they're starting to think is how do you actually take these models, instead of training them on everything that's on the web, focus on what you're trying to get that model to do. Now, my point is in your phone, you don't need to know what's on the 4th page of Shakespeare's Macbeth. In your phone, you need to know intent. You need to have contextual awareness and know what the user wants to do. And then you want to be able to parse that to use the orchestrator, or what I call an arbiter, to go and figure out how to get it done. You don't need all this in your phone. You can always go to the web to find that data. So I believe very strongly the AI phone is closer than we think. It's not 10 years away. It's maybe 3 years away, maybe 5 years away, based upon the fact that we're going to be able to take these files, make them more and more efficient, make the hardware more efficient, the software more efficient, and focus them on what we're trying to get done. So what does that mean? Today's operating system is a bunch of functional code calling apps, right? Or executable files, drivers, a lot of different things that you can do. The AI OS, a true AI phone, will have an operating system that's based on AI. Now, what you see here visually would be the ideal, which probably will happen in a timescale of 10 to 20 years, where you actually have general AI running in your hand. It probably will happen at some point in time, but that's science fiction. That's a long way out right now. We don't have the visibility to get there. But we do have the visibility to do is to build a small language model that can parse all of the data coming in, including your voice or what you're putting on your screen, and figure out what you want to do. Right? Now, there's a problem. If any of you have really sat down and done large language models and sat and ran the input, ran the prompts, it's actually really hard. It takes a long time to figure out the right prompt to get the right data you want out of an LLM. So I believe the first step of an AI operating system will be to understand your intent. It will translate your voice. It'll translate where you are. It'll be proactively looking at what you're doing at that point in time, the shopping center, for example, that I brought up earlier. And it will then decode that intent to an input into an arbiter model that will actually figure out how to get what you want done. I don't think there's going to be one big model to start with that solves all of this. It just doesn't make sense. But we can break this problem down into fixable problems by saying, I'm speaking to my phone, it knows where I'm at, it knows my voice, it knows my history, and therefore it knows what I want to get done. That model sends that input into a larger model that says, how do you get it done? Do I have to go hybrid and go to the cloud? Am I searching query? I brought up search earlier. If I'm searching for something, it will know, am I searching for that picture that's already local and be able to find it that way, or will it have to go to the cloud and use a larger engine? All of that's going to be done based on AI. Now, how do we make this a reality? Engineers on my team also like cats, and they also think that sometimes I'm talking about too much science fiction. It's my job. I like to think about what's coming next. We talked earlier about hardware collaboration, right? All of these devices are going to have to talk to each other. There's going to have to have software that mixes it all together. Contextual awareness. 𝗀𝗚𝗍 at Qualcomm said a couple weeks ago, I really liked it. I saw him speaking at an event. He said, your phone should know you better than you know your phone. Your phone should know you better than you know your phone. That's going to be part of an AI phone. Federated learning. The phone's going to learn your habits over time. What you like to eat, when you like to exercise, what movies you like. It's going to be able to pick this up. Imagine having a glass on top of it where it actually sees what you're seeing in real time and is able to search based upon just what you're looking at and know that that's something you'd be interested in buying or not. So you're not just inundated with a bunch of data based on ads. You're getting the data that you really want because your phone knows you. Yet, at the same time, do you want all that data in the cloud? I don't. Some people may not care. So there needs to be privacy models built that aren't there today. Now, different generations have different feelings about privacy, and it needs to be tunable based upon that. But we most likely don't want all of our health data going into the cloud. We don't want all of our banking data going into the cloud all the time. We want some of that to be held personal for us, what we like to eat, all of those things. And it has to be collaborative across the hardware once again. One interesting debate that we've been having for many years is if you didn't have a screen, what would your phone look like? If you didn't need a screen, what would it look like? Are the folks at Humane.io right? Are we going to have a little pin that's just clipped on? Is Meta right that we're going to have glasses with a little pod? Is Apple right that you're going to continue to have this screen and maybe it's foldable and everything else, but you're going to continue to have it? My personal answer is there's room for everybody. I don't believe in convergence in terms of device convergence. Everybody's always talking about this is a new device. It'll do everything for you. You don't need any other device. If I look at my desk at work, I have 3 monitors on it. I have an iPad, I have a PC, I have a phone. Truth is, there's a proliferation of devices because we all want something that's very specific for what we're going to use at that time, and that is going to continue. We are consumers, and we're going to continue to be consumers. We're going to want these different things. So, will there be devices that don't have screens? Sure, absolutely. But at the same time, if social media is being something, when I get home from work and I'm going to see my teenagers sitting there scrolling like this all the time, that's a usage model that's probably not going away. We've talked about the UI design, the interface. Another debate is, if you can talk to your phone, do you need a screen? And my answer is, I want a screen. I still want to be able to have private data going through my phone. One of the keys that's going to have to happen is all of the proactive data that's being driven to the UI for audio also has to be there for your screen. I want my screen to pop up and say, hey, check your bank account when I'm standing in line at Macy's, to warn me that I'm about to overspend. I don't want to have to overspend first and then find out later. Again, that's going to be the AI phone, proactively helping making your life better and easier through AI, through hardware, through software. Now, how are we going to, again, theme, how are we going to get this in our hands? It's going to take a lot of work across the ecosystem. It's going to take a lot of work from Qualcomm and MediaTek to go out there and build SoCs that are going to have the hardware capabilities of getting this to happen. It's going to take a lot of work on their side to get the software that's efficient enough that you're not draining your batteries. But there's one other thing that's happening in the phone today that happened in the cloud already. That's the memory wall. On this graph, the pink line is the gigaflops in a very high-end mobile chipset over time. And you see it's starting to grow exponentially, just like in the cloud. The hardware capabilities in the phone, the GPUs, the NPUs, the CPUs, all of which are going to be having to work together to be running multiple models at the same time, are becoming tremendous. Memory is growing, the speed of memory in green is growing at more of a linear rate. So there's another memory wall that we have to tear down. How are we going to do that? Well, there's quite a few possibilities. First of all, I want to be clear, I'm not announcing any products today. I'm simply talking about technologies that are capable in the future that we as an industry have to work together to consolidate on. Because the only way this is going to actually work in someone's hand is if we can get economies of scale so that we can build them cheap enough that people will want to buy them. Doesn't do us any good to go build a $20,000 smartphone that does all this work that sits on a shelf or never even gets shipped. LPDDR6 is the next generation standard for LPDDR. It's coming. JEDEC is not quite complete yet, but it is definitely coming. You're going to see it in your phone. It'll provide about a 50% improvement in throughput with some power reduction. So it'll help bridge that wall. It'll be in your phone. It'll be in your laptop. It's even going to be in data center. LPDDR6 is coming and it's going everywhere. Great, great next generation product. But it wasn't designed with AI in mind. It wasn't designed to break down the memory wall. We need more after LPDDR6. Processing in memory, or PIM. PIM is a technology that has been around for many, many years. The idea is very simple. In a classic von Neumann architecture, you have a CPU and a memory, and all the data is held in the memory and all the compute's done in the CPU. This makes a lot of sense, right? Specifically for a CPU where it's a lot of general processing. But when you look at AI and you look at what's happening with inference, you find out it's not a lot of general processing. It's actually a lot of convolution math. Multiply, accumulate. A lot of multiply, accumulate, sequential math. That's why GPUs were great for it to start with. That's what MPU architectures are. So there is a possibility to take the processing and memory architecture where you put the logic for this type of math underneath the memory on the same silicon. You take advantage of that silicon to do this simple, relatively simple math. What that allows you to do is save a ton of power. You don't have to transfer the data back and forth. You don't have to worry about the data path inside of an SoC. You just write the data to the memory, let it compute, figure out the inference, and read it back later. Now, our competitors have also talked about this. So this is something that we, again, as an industry, we're looking at as a technology, and we need to figure out how to make it real and get it in people's hands. We see a relatively simple architecture for a PIM solution that will be focused on mobile and client, that would be a great value proposition without adding a ton of cost. Because in order to solve this problem, we actually have to think through power, performance, and cost. We cannot forget cost. In the cloud, they're spending trillions of dollars. You're not going to spend trillions of dollars on a phone. So that is a very, very key point for a consumer product that we cannot lose sight of. PIM has the potential to be a technology to help solve that. And the last one I want to talk about is Wide I/O. Wide I/O, again, is a technology that's been out there for many, many, many years. HBM3E, that tore down the memory wall in the cloud, is essentially an ultra super Wide I/O product, right? That's essentially what it is. The concept of Wide I/O is you have a lot more pins, and therefore you don't have to run them as fast to get as much data across. Really, really simple, right? The problem statement with Wide I/O is it takes a lot of beachfront on that silicon. It's expensive, right? So can we afford to do a Wide I/O solution? From a technical point of view, purely technical, Wide I/O looks great for AI in your phone. What we need to try to do is find the balance between cost, power, and performance. I've even had multiple people in this industry come up to me in the last 18 months asking me for mobile HBM. Not kidding at all. Mobile HBM. I have no idea what that means. But if I listen with a calm mind, and I think about 5 years from now, and I think about 10 years from now, there may be a space for something like that. Maybe there will be new economies with AI that we don't know about today that would allow them to afford that. So what do I know? Not a lot. I know that AI is here in the cloud. I know it's starting to show up in your hand. I think it's clear to me that your UI in your phone is going to be heavily influenced by AI. It's clear to me that query in your phone is going to be heavily influenced by AI. And I think it's very likely there's going to be new form factors that come out. But in order for it to really get there, we have some serious problems to solve. One of which is the memory wall. And the other thing I know is that Micron, just as we did with HBM3E, is going to be leading the way to solve the memory wall in mobile. AI already is everywhere. And everywhere there is AI, you see Micron. Thank you.